Hello class, welcome to your first video lesson of Advanced Algebra A. What we're going to be talking about today is section 2.1, Relations and Functions. As you can see when it says section 2.1, that means chapter 2 and the first section of chapter 2. The reason why we're not starting on chapter 1 of our book is because chapter 1 is, I feel, more introductory, and you guys don't need to spend the time on going through that stuff because you have already learned it before. With that being said, chapter 2 is also a chapter that I believe you guys have all dealt with before in intermediate algebra, so hopefully this will be kind of a review for you, this first chapter, and it'll be a nice way to ease into the school year. So what we're talking about today is relations and functions. We're going to first define what those are. What a relation is it is a set of ordered pairs. So this relation has 5 ordered pairs in it. So if we were to identify these ordered pairs or identify this relation, you guys all remember this, I'm sure. We label our points in x, y ordered pairs. So this point right here is going to be at a negative 1, 2, 3, 4, and up and down 0. So negative 4, 0. My second point, going from left to right, is going to be a negative 1, 2, 3, positive 1. So a negative 3 and up 1. My third point, I'm going left and right 0, and I'm going down a negative 2. So 0, negative 2. My fourth point, I'm going to the right 1 unit and up 2 units. So it's 1, 2. And my final point is going to be to the right 1, 2, 3 and up 1, 2, 3. So right 3, up 3. So I have correctly identified my relation. All it is a set of ordered pairs. Now the domain. Domain and range is something that we're going to be talking about a lot this year. Every single function that we do, we're going to be talking about what the domain is and what the range is. So let's get used to hearing those words. What the domain is exactly what it states right there. It is the x values. So the x values are obviously the ones that come first in our ordered pairs. So I will circle our x values. Here's our domain. Our domain is a negative 4, negative 3, 0, 1, and 3. Those are all of our x values, so we would call those values, those 5 numbers, those are the domain. And in the exact opposite way, the range is the y values. So I'm going to underline all my y values. My range is 0, 1, negative 2, positive 2, positive 3. So that is the domain and the range. We're going to talk about that in every graph that we do. It's going to be the domain being the x values, the range being the y values. All right. Now let's label what a function is. In class, this is a very basic definition, but it's something that is very, very important because, like I said, we're going to be talking about the domain and the range of these functions with every chapter that we do. And so all we're going to be talking about basically in Advanced Algebra A and Advanced Algebra B is different kind of functions. There's linear functions, quadratic functions, polynomial functions, cubic functions, a whole variety of functions. That's what we talk about in math. So let's understand this definition that I believe that you guys have had before. A function is a special type of relation in which each element of the domain is paired with exactly one element of the range. It sounds kind of confusing at first. In layman's terms, it's kind of just at the bottom. In order for it to be a function, it must pass the vertical line test. And I believe that you guys have been introduced to that before. We'll do that again on this slide. All right, so for these 3 graphs, what it asks is it tells us name what the relation is and then tell us if it's a function or not, yes or no. So naming the relation I don't think is very difficult. You guys could probably do this faster than I could say it. All you have to do is label where these 3 points are. So my relation is going to be negative 1, 2, 3, positive 1. Negative 3, positive 1. This one is at 0, 2. And my final one is at 2, negative 1. So there's my first graph. We'll just do my relations for all 3 graphs. This one, my furthest left point is at negative 2, positive 1. The middle point is at right 1, up 2. and my third one is at right 3 up 1. There's my relation for my middle graph. And now my relation for my last one. Remember what a relation is, class. All it is a set of ordered pairs. So for this one, it's going to be at a -1, -2 for my first point. My second one, we'll say my second one will be this one right here. It's going to be right 1, down 1. And my third one is going to be right 1, up 2. Alright, I have successfully labeled all of my relations. So now I got to answer this question. Is this relation a function or not? If it is a function, that means that it passes the vertical line test. And what that means is that when I take this vertical line right here, it could touch one and only one dot at a time. If it touches more than one dot, it fails the vertical line test, and that tells us that it is not a function. So as I go from left to right, I'm touching 1 point, 1 dot on my relation. As I keep on going left to right, I touch only 1 dot. As I keep on going left to right, I'm still only touching 1 dot. So as you can see, at any vertical line here, at any of these vertical lines, it touches only 1 point. It never touches 2 or more. So if that is the case, we would call this a function. So we could just write, is this a function? You would write yes right here. Leave a little bit of room after it, because I'm going to come back to this page after talking about another term that we're going to have on the next slide. All right, so now for our next one, our middle one. We take our vertical line, and as we go from left to right, does it touch one and only 1 dot at a time? Meaning it does not touch 2 or more. 1 dot, 1 point, 1 point. This one is also a function. We would say yes for this one as well. It passes the vertical line test. So now for our third one, I'm taking my vertical line, and it touches once right here, but as you can see, as I go to the right, right there, it touches 2 points with just 1 vertical line. If that is the case, we rule this one out as being a function, and we say no. A function has each element of the domain is paired with exactly 1 element of the range. And this one domain right here, that domain being a +1, is paired with 2 elements of the range, -1 and +2. So if that is the case, we say that it is a no. This one is not a function. Class, I feel like this is pretty easy to tell using these graphs right here. Sometimes you aren't given the graphs. All you're given is the relation or the ordered pairs. So here's one thing that I want you to write down in your notes. It helps me anyway. In order for it to be a function, the x values, the x's, cannot repeat. If the x values repeat, then you know for certain that this is not a function. However, the y's, they can repeat. The y values can repeat, and it could still be a function. The x values are the ones that cannot repeat. So as you see on this one, on the middle one, I have a y value of 1 and another y value of 1. And this is still a function because my y values can repeat. However, on my third one, I have an x value of a 1 and an x value of a 1. My x's just repeated. If ever my x's repeat, then it is not a function, because with a function, the x's cannot repeat themselves. So hopefully that makes sense on your accelerated math. If it asks you if it's a function or not, If they give you a graph, just use the vertical line test. If they give you a relation or a set of ordered pairs, just remember this trick. The x's cannot repeat. The y's can repeat. All right, I hope that makes sense to you. That is what that's what a function is. Next one is a special type of function. It's called a one-to-one function. With a one-to-one function, it's a function in which every y has exactly one x. You're going to check this by using the horizontal test. I also want you to write this down in your notes. You can check it by using the horizontal test. This one, the x's cannot repeat. And this one, the y's also cannot repeat. So for it to be a one-to-one function, it has to pass both the vertical and the horizontal line test. So when I go back here, I hope this is okay with you guys. I'm going to erase some of my mess up here so that it's a little bit less confusing. I'm going to take my vertical line, and I've already done the functions, yes or no, so on and so forth. So now I'm going to see if it's a one-to-one function by using the horizontal line test. And the rules remain the same. It can only touch a point only once for every horizontal line. So as I go down, it touches once, it touches once, it touches once. So as you can see, this one passes both the vertical and the horizontal line test. So is it a function? We would say yes. And not only is it a function, it's also a one-to-one function. We know that because it passes the vertical and the horizontal line test. And also, class, remember the hint that I told you right here? The x's cannot repeat and the y's cannot repeat. If we look here, do any of my x's repeat? A -3, 0, 2. No, the x's do not repeat at any time. Do my y's repeat? 1, 2, -1. Nope, they're all three different points. So this one is not only a function, but it's also one-to-one. Moving onward, looking at this one we said it is a function, but is it a one-to-one function? As we go down, it touches only once, but this horizontal line, boom, it touches two different points, doesn't it? If at any time it touches 2 points, we know that it is not one-to-one. So we would say, yes, it is a function. However, it is not one-to-one. That is a special type of function. So once again, going with this trick that I told you, you could use the horizontal line test. And if they just give you ordered pairs, the x's cannot repeat, the y's cannot repeat. So do my x's repeat? A -2, +1, +3. My x's do not repeat, but do my y's repeat? 1, 1, 2, 1. So because this one and this one, they repeated themselves on the y, we know that it's not a one-to-one function. The x's cannot repeat and the y's cannot repeat for it to be one-to-one. And then on my last one, if it's not a function, then it's certainly not going to be a one-to-one function. So we don't even have to worry about saying if it's one-to-one or not, because we already know that it's not a function. If it's going to be a one-to-one function, it first has to be at least a function. So we don't even have to worry about that. All right, so now what I want you guys to do is I want you to pause the video, and I just want you guys to see on your own, tell me if this is a one-to-one function. Oh, never mind, I already told you the answer. This is an example of a one-to-one function. As you can see, the x's do not repeat themselves, 2, 4, and 6, and the y's do not repeat themselves, 7, 5, and 3. So that's a quick way that you can tell if it's one-to-one or not. And as you can see, this one is. We could also use our vertical line test to see if it's a function. And there we have it. We know it's a function because it only touches one dot at a time, 1 point at a time. That's how we know it's a function, and here's how we know it's one-to-one. If it touches one dot at a time when we do the horizontal line test. So number one, this one certainly is a one-to-one function. Onward to our next one. This one is not a one-to-one function, and how do we know that? The x's do not repeat themselves, so this tells us that it is a function, However, the y's cannot repeat if it's going to be a one-to-one function. Do the y's repeat? 5 and 5. So because that 5 shows up twice, it's repeated itself, we know that it's not one-to-one. To do the vertical line test, this tells us that it is a function, 1 point, 1 point, 1 point at a time. So it is a function once again. Make sure you get that into your head. It is a function. However, it's not that special type of function in which it is one-to-one, because right there it touches 2 different points. So I hope that makes sense to you. I know that you guys have had this definition before in the past. Hopefully this is a little bit of a refresher on what a relation is and what a function is, along with a one-to-one function. Be sure to let me know if you have any questions. I'm now going to record a different video on the rest of the notes.